Good evening, ladies and gentlemen. So, in preparation for MSM tests and final exam, we are going to answer tutorial sheets on limits and differentiation. So, we are going to be answering questions from two different tutorial sheets. One is the NS tutorial sheet, and the other is Business Mathematics tutorial sheet. So, I want you to see and understand that mathematics is the same, is fundamental. The one from NS, anyone from NS can answer any tutorial sheet from the School of Business Mathematics, and the one from the School of Business Mathematics can also answer questions from NS because they are just one and the same things. Differentiation is the same everywhere you go. Limits are the same everywhere you go. Integration is equally the same everywhere you go. So mathematics is fundamental. Even in America, the same things you are doing here. People in America, they are answering the same thing. So there's nothing like, oh, this is different, this is different. They are all one and the same thing. So let's not waste time and start answering. So now, today, we'll do something very different from what we have always been doing. This time, I've been feeding you answers. Now I've seen one thing. Feeding you answers won't take you anywhere. So today I want to be giving you answers. I'll be giving you concepts. Mathematics is not about you mastering how to answer a question, mastering how the final answer was. Mathematics is about knowing how the flow of question is going. How is this question being answered? That's what mathematics is all about. So today I want to be finishing answers, but I'll just be showing you how to get about an answer. So I'll be showing you a method to answer, not answers. I want to be showing you answers. I'll be showing you methods. So let's start with question number one. So number one says evaluate the following questions. So we have I. I is limit as x approaches 5. So we are starting with limit. So we have in brackets 2x squared minus 3x plus 4. So how do we answer a question as limit approaches a certain number? So this is how we go about with it. So for this one, number one, I will try and answer it myself. So this is how you answer it now. So for this limit as x approaches 5, this is just a straightforward question. It's showing you that where there is x here, you're putting what? You are putting this 5 here. So 5 here, 5 here, we're good to go. So let's try and do it. It's equal to. So the moment you get this 5, you put it here, this and that, then what disappears from the equation because you have used the 5 they have been talking about. So it will be 2 open bracket 5 squared minus 3 5 plus 4. So from here you will now do, what is 5 squared? 5 squared is 25. So it's 2 times 25 minus 3 times 55, that's 15 plus 4 is equal to, you will finish the answer from here. From where I've ended with on question 1, you can finish it up yourself. It's only putting the final answer, that's all. So we go to number 2. So number 2 is limit as x approaches negative 2 of x to the power 3 plus 2x squared plus 4. Then 5 minus 3x as the denominator. So the entire thing is just as the denominator should never be equal to negative 2. So what you are going to do is just substituting direct because eventually you replace 2 from the denominator. So you just first check from the denominator. When you put 2 on the denominator for x there, it won't change anything. It won't be a 0. So you go direct to replacing. So you just put where there is x to the power 3, you put a negative 2 there, like plus where there is x to the power 2, you put a 2 there. It will give you negative. On top here, it will be negative 8. If you substitute properly, it will be negative 8 plus 8 plus 4, which will give you just a 4 on top there. Then below there, it should give you a positive 9 if you do all your calculation properly. So we don't have to solve that one. Then go for question number 3, limit as u approaches negative 2. Well, just because you see there is a root there, you even get confused. That's direct and straightforward. You just replace 2 where there is u, you put negative 2 plus, again where there's u, you put -2. You find the answer inside the limit, the root there. Then if the answer, since it's a square root there, if you can find an answer, you answer. If you can't find the answer, you leave it like that. You don't have to answer in points. Then you go to number 4. So number 4, that's one I'm going to answer with solving. So number 4 we have, part 4 we have limit as x approaches 2. Then you have x squared plus x minus 6 over x minus 2. So from what I said on question number 2, I said the denominator should not be equal to 0. So okay, let's go and answer it by proving. So here, so let's try to replace. So when replacing is equal to, let's first go on the denominator here. So we have positive 2 here. When you do 2 minus 2 here, then 2 squared plus 2 minus 6. So here, the denominator will just give you a 0. So whichever number, let's just assume here it gives you, okay, this is a 4 plus 6, it will also give you 0. 0 over 0. If I ask most of you, what is 0 over 0? About 60%, in fact, maybe 75% of you will say the answer is 0. Well, that's not the answer. The answer is not 0. The answer is undefined. You can prove it on your calculator. But so also, mathematicians also will say the answer is infinity. So it's either undefined or it's infinity. It's one and the same thing. So why? Whenever any number into 0, it's 0. But 0 when 0 is a denominator, 0 into any number, it can be 1,000, it can be 1,000,000. The answer is undefined, or the answer is infinity. Because 0 can go into 1, but the number of times 0 can go into 1, it's unknown. Because if you do 0.1, 0.1 can go into 1, but with a large number. 0.001 can also go into 1, but with a large number. So the more the denominator decreases, the higher the number goes up. So the value for the answer goes up. So that's why we cannot determine the number of times 0 can go into another number. That's why we just say it's undefined or it's infinity, because the number is too big for us to assume it. So now under limit, we don't want the answer to be undefined. So what should we do for it not to give us undefined? That's where application of limits comes in. That's where people will see that how you have really understand limits. So how do we answer it? We go back to the question now. You start assuming the question. What do we have in the question that will make you the denominator and the numerator to be the same? You assume the question, you go to the numerator here. You see from the numerator, this is a quadratic equation. So from a quadratic, we have x squared plus x minus 6. You can factorize the numerator using the product, sum, and factor rule. So we have said we have x squared plus x minus 6. So when factorizing, we have the product, it's -6, the sum is +1. So which two factors will give you a -6 when you multiply, but a 1 when you add them? You will see that it's -2 and +3. So we just replace here. So it will be x squared plus 3x minus 2x minus 6. That's our numerator. So you just get the same numerator and you replace it from the overall question you have been given. So it will be limit as x approaches 2 of, you put x squared plus 3x minus 2x minus 6 over x minus 2 is equal to. Then from here you can do the factorization. So it will be, what's common between these two? It will be x. So it will be x plus 3. Even here, what's common here? It will be -2. It will be x plus 3 over x minus 2. So when you group them, it will be equal to x minus 2, x plus 3 over x minus 2. As you can see, from the denominator and the numerator, you have something that is common, which is x minus 2 and x plus 2. So what you can do from here, you can cancel these two. They can cancel, giving you the only x plus 3. From where you can use now the limit. So it will be, in short, to be limit as x approaches 2 of x plus 3. So just replacing 2 here, you'll find the answer yourselves. So we now go to part 5 of question number 1. So part 5 is saying find the limits as t approaches 5, but the answer should be, it should be limits as x approaches 5. So it will be limits as x approaches 5 of x minus 5 as the numerator and x squared minus 25 as the denominator. Okay, for limits, let's just try to answer it the direct way. So let's try to answer it. So from the numerator here, since you have said x approaches 5, so you will put a 5 here, minus 5 over 5 squared minus 25. 5 minus 5, it's 0. 5 squared, it's 25. 25 minus 25, it's 0. The answer is giving us undefined. But again, the same words undefined. That's the thing we don't want here. We don't want an answer undefined here. So what do? We'll go back to the question and find the way. How can we simplify this question now? So we'll answer it from down here. So it is equal to. So from here, let's look at the question closely. How can you make the denominator and the numerator to be quite the same so that you can remove something, you get away with something? What can we do from the question here? As you can see now down, you have x squared minus 25. So from the denominator here, you remember one principle you have been learning since high school, the principle of difference of two squares. So you have the difference of two squares here. You have x squared minus 25. So you will do as, it will be limit as x approaches 5. Then you have x minus 5 over x squared minus 25. So what number do you multiply 2 times? It will give you 25. So you will see that it's x squared minus 5 squared, which will be the same as x minus 5 over, for difference of two squares, it will be x minus 5 x plus 5. So you have something common in the numerator and something common on the denominator. So cancelling this, it will be is equal to 1. So it will be limit as x approaches 5 of 1 over x plus 5. You can find the answer from here. It's as simple as that. Let's try to see another question which we can answer from here. So now let's try to change a tutorial sheet and answer some more questions, but the same approach. So let's go to question 3 of the tutorial sheet. So the question 3 reads, find the limits as x approaches 0, limits as x approaches 0 of root of x plus 1 minus 1 over x. So even the same question, from what we are doing from the previous question, you see that x is the denominator and the limit of x is approaching what? 0. And we said the denominator should never be equal to 0. So if you put here the number 0 here on x on the denominator, it will give us a undefined here, this 0x here. When you put a 0 here, whatever number you have on top here, it will give you undefined. So we have to find a way to make the function defined. So what are we going to do? Well, look at the question closely. Here you have a root of something. You go back to that semester 1. We have limits. When SADS, from SADS, what do we do when you have a numerator with a root or denominator with a root and you want everything to be equal? Well, you rationalize. So this time we're rationalizing the numerator. So what are we going to do? To the numerator, we're going to multiply it with its conjugate. So what's the conjugate of the numerator? So the conjugate will be, you are multiplying it by root of x plus 1 as it is in the root, or minus. So here we have a minus, we will make it a plus 1. Same as on the denominator, it will be root of x plus 1 then plus 1. So, and from, if you remember the rules of SAT, when you're multiplying, this is A, this is B. So this is A, this is A, this is B, this is B, and this is negative, this is positive. So when you are multiplying, you just multiply A times A, B times B, because of the difference in signs. So it will be is equal to this times this, it will be a squared. So squared and squared root will do what? Will cancel. So we will only remain with x plus 1 here. Then negative 1 times positive 1, the answer will only be a negative 1 over. So here you will just multiply, it will just remain everything, x plus 1 plus 1. So on the denominator here, you must leave it like this. You don't have to follow it. By the word follow, I mean you don't have to multiply it. You just leave it like this, because you have to find the way in which you can cancel something from the numerator and the denominator. So what will happen from here? You will see that here you have 1 minus 1. So these two can do what? You have positive, you have negative. They can cancel. So you only remain with the x here. Again, you have x root of x plus 1. We have another. Okay, let's just do it from down here. So we have said we remain with x, because 1 minus 1, positive 1 and negative 1 will cancel each other. So you have also the denominator, we have x root of x plus 1 plus 1. So as we can see now here, so let's not forget its limits as x approaches 0. So you have x here, you have another x here. These two can do what? They can cancel each other. So it will be 1 limit as x approaches 0 of 1 over root of x plus 1 plus 1. From where you can do the substitution, you get a non-zero answer. That's the limit of this question. Let's do another question from the tutorial sheet on question number 3. So we are going to do question, okay, let's do part C, not even D, we'll do part C. So part C is limit as x approaches positive 1 of root of x plus 3 minus 2 over x minus 1. So from here, I've seen here as well, we have a 1 here. Looks as x approaches 1. So here, when you put 1 here on the denominator, it will be 1 minus 1, which will give us a 0. And the 0 I've said is giving us undefined. So you are not using this limits as it has been given. So you are going to use the same approach as we answered the previous question. So you are going to multiply the numerator by its conjugate and the denominator by the conjugates of the numerator, which will be equal to, not even equal to, so multiplied by root of x plus 3 plus 2 over x minus 1. So even from here, from the denominator I've said it will be root of x plus 3 plus 2. Then multiplying these two, you will get simply x plus 3, 2 times 2 is 4. So it should be a negative over. So here you don't even have to follow the denominator as I've said, you just leave it as it is. So it will be x minus 1 multiplied by root of x plus 3, then plus 2. So from here you will see, when you work out this and this will be the same if you do your multiplication correctly. So the entire this will do what? Will simply cancel. So you only remain with 1 over, so it will be root of x plus 3 also plus 2. From here you can do this direct substitution, because you are answering as the limit as x approaches 1. So you can put your 1 here, it will give you a 4. Root of 4, it is 2. 2 plus 2, it's 4. So the answer will give you 1 over 4. This one I've even answered it for you. So from this question, we are done. So now let's go and do limits as the function approaches infinity, as x approaches infinity. These are most questions. They are most highly questions, and these questions are very, very simple. So Let's do part A. So part A. Wow, it looks so expanded and so complex. So how do we do? So before we even start answering the question, let's simply first look at limits. What is the property of limits of infinity? That's how you simply understand this question and how you know how simple the question is. So whenever you answer in questions of limits, you have to remember one thing. So when you have been given f of x is equal to 1 over x, whenever you we have f of x is equal to 1 over x is equal to, so when you say that over here you say find f of infinity is equal to, so 1 over infinity, that's what you have here. So now for when you have 1 over infinity, the answer is simply 0. Why? So infinity can be a number. Okay, have you tried using a calculator? You do. So infinity can be any large number. So you do 1 over, let's say 3 billion. So you get as many zeros as you want. You can even put as many zeros as you want. As long as it's 1, yeah, even if it's 2, 3, 4, as long as this number is entered in here, you see that the value you will find, it's getting closer to 0. That's what limits is all about. So maybe you find the answer to be 0.00000000 something, then you say maybe 93 what? That's the question here. So the answer you will get is simply close to 0. So this one, you can see the number of zeros. The answer can just be, you can just say the answer is 0. That's what infinity is all about. So remember when you tackled the question which had 1 over 0, we said the answer is infinity because we said as the denominator gets smaller, the numerator increases. So the numerator approaches infinity because you don't know the number of times. Now when you have a very bigger number and you have a 1 there, 1 over a big number, it will be approaching 0 cross by cross. So even here, if you increase this number, you see that the value you find here to be approaching 0 even at a faster rate. That's what limits about as x approaches infinity are all about. So whenever you have been given a question about limits as x approaches infinity, whichever question you have to try to express it in this form, 1 over x. So it doesn't matter how many, even if it's x to the power 3, x to the power 5, the answer will still be the same because the x is still increasing at a faster rate. So even if you do, let's say we have infinity. So if you square infinity squared is c, still infinity. Infinity minus infinity is still infinity. Infinity plus infinity is still infinity. Infinity divided by infinity is still infinity. Because infinity, it's unknown. You don't know which number you are working it. Maybe this infinity is 1 billion and this one it's 1,000. This infinity is 1,000. 1,000 minus 1 billion still be infinity because it won't give you 0. If you square infinity, it will still be infinity. Infinity divided by infinity, it will still be infinity. That's what infinity works all about. So now let's do a question from the tutorial sheet. So we are doing question number 4 from the tutorial sheet. Question number 4. So let's answer part A of the tutorial sheet. So we have part A is you are finding the limits as x approaches infinity of 4x cubic minus 2x squared plus 7 over 2x power 3 plus 5x squared minus 3x plus 1. So now for this limit, I said the answer, for you to find a suitable answer, how you find the suitable answer, you have to express the entire this numerator and this denominator in the form of 1 over x. So how can you express it in the form of 1 over x? So let's quickly go to the numerator here. Let's try to say on the numerator here, since the highest power of x we have is x to the power 3. So let's multiply the numerator by x to the power 3. So multiplied by x power 3. So let's say 1 over x power 3. So which will simply equal to, so for now, let's not use the limit. First, let's just find the answer. Then we come back to the limit. So it will be 1 over x to the power 3. So this times this, you see that it will be 4x to the power 3 over x to the power 3. So that x to the power 3 and x to the power 3 can do what? They can cancel each other out. So you only remain with a 4 here minus 2x squared multiplied by this. It will be 2x squared over x to the power 3. So here you have a degree of 3 on the numerator, or on the denominator you have a degree of 2 on the numerator. So 2 can cancel. So here you only remain with x. So it will be 2 over x plus 7 multiplied by this entire function to be 7 over x to the power 3. 7 doesn't have any x. 7 is a constant, so it will only still remain 7 over x to the power 3. Then now let's go now back to the denominator. So for the denominator, let's also check it's the highest power it has. It's also x to the power 3. So let's do the same thing with it. So you do 1 over x to the power 3. So you're multiplying by this. So 2x to the power 3 times 1 over x to the power 3. The answer will only be 2. Then plus 5x squared multiplied by x to the power 3. The answer will only be 5 over x. From what we did to the numerator, you have already understood is 5 over x. Then you have negative 3x multiplied by 1 over x to the power 3. So if you have 3x here, x and the 1x from here will cancel. You only have negative 3 over, you had 3x here, 1 has cancelled, it will be x squared. Here you have 1, so 1 times this is just the entire function as it is, plus 1 over x to the power 3. So now we have expressed the question from what the answer I gave you from the overall function. So this is an identity. So I told you that everything you have to express it in this form, 1 over x, and that's what we have done here. It's 1 over x, 1 over x, 1 over x, 1 over x, 1 over x. It doesn't matter the value you have here, because you can do it 5 multiplied by 1 over x. That's the same thing. So we have expressed it in the form we wanted. So now let's bring back the limit. So it will be limit as x approaches infinity. So we have 4 minus 2 over x plus 7 over x to the power 3 over 2 plus 5 over x minus 3 over x squared plus 1 over x power 3. So now let's just go direct to answering. So here I said when you have 1 over x, the answer gives you as x approaches infinity. So for 4 is a constant. You cannot do anything to 4. Even if you have a limit here, so it will still remain a 4 here from the properties of limits minus 2 over x. So it will be 2 over infinity. 2 over infinity, the answer is 0. So it's minus 0 here. 7 over x to the power 3. So it will be 7 over infinity to the power 3. And I said infinity to the power any number is still infinity. So the answer will still be 0. So plus 0. Then on the denominator, we have limits of as x approaches infinity of 2, which is still 2. So here 5 over x will be 5 over infinity, which is just 0. So everywhere here will be 0, 0. So the overall answer will be a 2. That's how we answer questions on infinity. Also, let's now do part D. These other questions you see, do it yourself. So part D, since you have already understand the concept, so part D is limit as x approaches infinity. Root of x minus 3 plus root of x plus 1. So even here, it's just the same concept. Even if you have a root, don't make the root for you to get scared and you come out from writing a question or a quiz, a test, or even an exam. You even say, that sucks, doesn't know how to prepare questions. That question was tough. That's one and the same thing. The question we are doing here and the question on roots, just the same thing. As long as you know that you have to express your function to 1 over x, you never go wrong. So how will you express it in this function you have been given here? So it will just be the same thing. So inside the roots there, you just say to just be equal to, for now the limit, okay, let's just be going with the limit. So it will be limits as x approaches infinity. Then here you have, so inside the bracket here it will be root of x minus 3. So inside here, let's try to multiply it by, so you have 1 over, you have x here, so let's multiply it by 1 over x here, just inside the brackets here, we multiply by 1 over x, also plus, even here, root of x plus 1, we also multiply it by 1 over x. So to be limit as x approaches 0, then you have a root of 1 over x times 1 over x, it will just be a 1. X over x, it will be a 1 here, minus 3 times 1 over x, it will be 3 over x. You go to this one, it will be the same thing, root of 1 plus, what was the value here? So, oh, here it was 1. So it's 1 times 1 over x, it will be 1 over x. So it will just be simply limit as x approaches infinity. So here you have 1, limit of 1. Okay, let's just go direct to the answer. So let's cancel the limit. So we said when you use the limit, it disappears from the equation. So it will be 3 over infinity here. 3 over infinity is just a 0. So 1 minus 0 plus root of 1. Again, 1 over infinity, it is a 0 plus 0. From where you can find your answer, I'm sure your answer, if you do your calculations well, the answer should give you a 2. You are done. That's all about limits. So there's nothing difficult about limits. So we have answered tackled questions as limits approaches any number, limits approaches 0, and limits approaches infinity. So it can be negative infinity, it can be positive infinity. The question is all about the same thing. If you have a negative infinity or you have a positive infinity, it's one and the same thing. Like question B, example B and C. Just because you have been doing infinity as a positive, they give you a negative. You even get wrong, my dear. This negative will not affect anything for you. Or as long as you express it in the same form, 1 over negative infinity is to negative, which is 0. Negative 0, it is still 0. So there's nothing for you to get worried or sick about. So for question B and C, you can easily do them yourself. What's how, what? No, stop complaining. Mathematics is easy if you just understand the concept. No, don't understand the answer, understand the concept. So this time we are just understanding the concepts. So let's continue now with limits. So let's do another video on now. This time we're going to do something more different from what we've been doing, but add questions, especially in quizzes and tests. Whenever you have been given a quiz on limits, I'm sure this question is always there. And also tests, they like this question a lot, like a lot.